In this presentation, I will be discussing the enzyme aldolase. Aldolase is a homotetramer with a lysine residue that is found in plants and animals. This protein is coded for by the aldoa gene on chromosome 16 in humans. Being that it is an enzyme, aldolase is naturally produced in the body to catalyze biochemical reactions by lowering the activation energy of a reaction. The primary role of aldolase is to work as a glycolytic enzyme that catalyzes reaction 4 of glycolysis. This reaction is the cleavage of fructose 1,6-bisphosphate to form glyceraldehyde 3-phosphate and dihydroxyacetone phosphate, which are both 3-carbon molecules. This reaction is an aldol cleavage, which is a carbon-carbon cleavage reaction of an aldol to form smaller carbonyl compounds. An aldol, which can be seen here in this picture, is an aldehyde or a ketone with a beta hydroxyl group. On the other side, in this picture, we can see some examples of some carbonyl compounds. Here we have an image of the enzymatic mechanism of aldolase. In the top circle, we have the enzyme in its free form. In step 1 of the mechanism, the enzyme binds the substrate fructose 1,6-bisphosphate. As I mentioned earlier, aldolase has an active site lysine. In step 2, the carbonyl group of the fructose 1,6-bisphosphate reacts with the amino group of the active site lysine to form an iminium cation, which is known as a protonated Schiff base. In step 3, the C3-C4 bond of the carbon chain that came from the fructose 1,6-bisphosphate is cleaved, and glyceraldehyde 3-phosphate is released from the enzyme as a product. From this release of the glyceraldehyde 3-phosphate, an enamine intermediate is left behind. So this enamine intermediate is more stable than the enolate intermediate that is formed in this aldol cleavage that occurs when it's base catalyzed, meaning that when aldolase does not catalyze this reaction, an enolate intermediate is formed. And now when aldolase does catalyze this reaction, a more stable enamine intermediate is formed. And because this enamine intermediate is more stable and requires less energy for the reaction to proceed, the presence of aldolase in this reaction essentially catalyzes it. And it does so by forming this more stable intermediate. So in step 4 of the mechanism, the enamine intermediate is tautomerized and protonated, forming the iminium cation from the Schiff base. So in the final step, step 5, the iminium cation is hydrolyzed, releasing dihydroxyacetone phosphate, which is the second product of the mechanism, and the free enzyme is reformed. So to summarize, aldolase is an enzyme that catalyzes reaction 4 of glycolysis, which is the cleavage of fructose 1,6-bisphosphate to form glyceraldehyde 3-phosphate and dihydroxyacetone phosphate. In addition to this, the mechanism involves an aldol cleavage and the formation of a protonated Schiff base.